Running a plastic comb through your hair on a dry day creates a physical pull that makes your hair stand on end. This force is the result of static electricity. To understand this, we have three objectives. First, identify the electrical charges inside an atom. Second, explain how rubbing materials forces those charges to move. Finally, predict how charged objects react when brought together. Examining this simple interaction with a comb demonstrates the fundamental forces that govern the behavior of matter throughout the physical universe. Atoms are the building blocks of all solids, liquids, and gases. At the center of an atom is the nucleus. It contains protons, which have a positive charge, and neutrons, which have no charge at all. Negatively charged electrons swarm around this nucleus in all directions. Because atoms normally have the same number of protons and electrons, objects are typically uncharged or neutral. Crucially, protons are held tightly in the nucleus and never move between atoms. Any change in an object's electrical charge is caused strictly by the movement of electrons. We can create an imbalance of charge through friction. Rubbing certain materials together physically pulls electrons from one surface to the other. For example, when you rub a piece of polythene plastic with a cloth, the polythene pulls electrons from the cloth. This leaves the polythene with a negative charge and the cloth with a positive charge. If you rub Perspex plastic with a cloth, the opposite occurs. The cloth pulls electrons away from the Perspex, leaving the Perspex positively charged and the cloth negative. Static electricity is simply this trapped imbalance of electrons on the surface of an object, waiting for an opportunity to discharge. To predict how these objects will interact, remember this rule. Like charges repel each other. However, opposite or unlike charges will always attract. This image shows a lightning strike, which is static electricity discharging on a massive scale. It occurs when particles and clouds rub together violently, causing the clouds to become heavily charged. We see the same process with road tankers. As they move, friction between the tanker and the air, and the tires and the road, creates a buildup of static electricity. Because of this buildup, refueling is dangerous. Why do workers connect an earth strap between a tanker and an airplane before they begin refueling? The strap allows electrons to flow between the two vehicles until they have the same charge. This prevents a spark that could ignite the fuel. Let's review. First, protons are positive and electrons are negative. Only electrons move to change an object's charge. Second, friction from rubbing objects together transfers electrons, creating static electricity. Third, like charges repel and opposite charges attract. Now for a quick check. What type of charge does an electron have? The charge of an electron is negative. How do two positively charged objects behave when brought close together? Two positive objects will always repel each other. Understanding how these subatomic particles interact provides the groundwork for managing larger electrical systems. Mastery of these static charges is the first step in our study of electricity.